All right, which numbers do we want to see do go over? Have questions about? Show them on your hands. All right, the ones I'm seeing the most are 2 and 3, and then 5. So we'll do those 3. Right, so for number 2, evaluating, going back to the beginning of the year, we have these 2 variables. We're going to put each one in where we see them. So x is -1, to use parentheses, square on the outside, y is 3. So you can either do this all in your calculator or step by step. So this would be 3 times 1 minus 9. 3 minus 9 is -6. Questions on that? When you square something, especially if it's a negative, make sure you're using parentheses. That way it stays a negative times a negative and doesn't become a negative again. I'm going to show both of these in Desmos as well. For number 3, if we were solving this, we could distribute. Combine like terms. And at this step, you should be able to see a specific solution. Which type of solution would it be? So you could stop there, say this would be no. Or if you kept going, or if you practice at x equals sides, we get -6 equals 30, which I don't know. Questions on that one? And then number 5 on the back. Solve for y. So this is not your y-intercept. It's solving the equation to get y by itself. So get rid of 3x. And then divide everything by negative. This would be y equals positive 3/2 x minus 2. Would be the equation where we solve for y. Questions on that one? I'm going to show each one in Desmos really quickly. If you need me to come back to this, I will in just a second. So if you did the work in Desmos, remember that you can now do the work in Desmos, say that you did the work in Desmos for these. For number 2, you would put the numbers in directly, is one way you can do it. So you could put it in like this. You could type it in exactly as it is. 3. I think you have to use capital letters. If I were to add sliders, then I could change these values to be -1 and 3. And then it would again solve it with those answers. So either way, and then you would say use Desmos, and that would be your work. For number 3, if we type in the entire thing, 7x minus 6. Actually, I'm going to type them in separately. Because if I type them all in, you won't see anything. But if I type both sides in, I can see that these two lines are never gonna cross. So that would be a no solution case, and we're gonna talk more about that later. For number 5, if I want to solve that using Desmos, I would type the entire thing in. And to solve this in Desmos, you would have to look at your slope, look at your y-intercept. So y-intercept is -4, slope is 1, 2, 3, 4 over 3. Oh, that's not right. It's 1, 2, 3 over 0. And then if you find your slope and your y-intercept, you need to rewrite it without actually solving it. Any Desmos or other SharkBite questions? Need me to go back to anything? Look at your course calendar. There's some important dates. You guys have 2 Delta Math due this Friday. One we're gonna learn about today, tomorrow. The other one Thursday, Friday. And then the next Delta Math is next Friday, and one due the Friday after that. Your quiz is going to be in 2 weeks on Thursday. Test will be the following Tuesday. Flex days after that. I think I may have also changed that. This was the next one. Yes. So all of this unit will be on the next quarter. So whatever your grade is now will be your grade unless you retake, take missing tests. Also, the last day to do retake stuff and turning missing assignments is Wednesday, the 24th. So in 2 weeks from tomorrow. And then the last day, if you get all your retake stuff done, but maybe don't have time to retake that day, the last day to do just retakes, not retake work, is that Thursday, again in 2 weeks. So we don't have much time to get grades up if that is what you're trying to do. Questions about any of that? All right. So this unit, we're continuing linear functions, equations, and we're going to be talking about systems. So go ahead and take out your notes. And I'm going to give you some definitions and vocab that I want you to go ahead and fill in. Yes. Yes. Go ahead, Kat. So a system of equations are 2 or more equations with the same variables. So it's basically 2 equations with x and y. And the solution to a system graphically is the point xy where the 2 lines intersect or cross. The solution to a system algebraically is the point xy that makes both equations true. We'll talk about what that means here in a bit. Then I want you to graph these 3 to the best of your ability. So for intersecting lines, it should cross, making one solution. For parallel lines, they will never cross, which would be no solution. And then if it's the same line graphed on top of each other, that is infinitely many solutions. So the types of solutions has not changed. Now we're just putting graphs to those solutions. And then how we solve systems by graphing, rewrite the equations in slope-intercept form if it's not already. Graph the lines. And after we graph, we should be able to identify the solutions, whether it's 1, none, or infinitely many. When you finish writing all of that, go ahead and put your pencil down so I know that you're ready. We're gonna try examples 1 and 2. If you want a ruler, feel free to go grab one. So I'm gonna do this in 2 separate colors. You don't have to, but if it helps you see it better, do that. So for the first one, these are both already in slope-intercept form. How would I start graphing this first one? Where would I start? The line intercept of -8. These are 10 by 10 graphs. And that helps, that way you don't have to count. So start at -8, and then our slope is 1. So that means we can go up 1 to the right 1 as many times as possible, fill up your graph. And down 1, left 1 as many times as possible, fill up your graph. Once you have all of your points, go ahead and make a line. Make sure it has arrows, because lines go on forever and ever. Okay, then graph the other one. So this one has a y-intercept of 1. Slope is -2. What directions could I go to get a negative slope? Down.
Right.
Not down and left, but I could go down and right, or what and left? Up and left. So up to left 1 as many times as possible. Or down to right 1 as many times as possible. As you're doing this, you'll notice which one crosses or which one is the intersection point. Where do those 2 lines cross?
Right.
3, -5. And that's it. So graph it, find where they cross, that is your solution point. Questions on that? Okay, let's do number 2. Same process, y-intercept starts at 9. Slope is 1/2, so I can go up 1 to the right 2, down 1 to the left 2, as many times as possible. Draw a line. Connect all your dots. And then draw the other one. That one starts at 6. Slope is -1, so down 1, right 1 as many times as possible. Up 1, left 1. Where do those 2 points cross? 2 lines cross? -2, 8, yes. Go on to the next page. So we're gonna do number 3, and then any you guys wanna see to go over, and then we'll see. So both of these are in standard form, so we have to solve them both. I'm gonna do this simultaneously. Get rid of 3x by adding it to the other side. And get rid of x by adding it to the other side. So we have y equals 3x plus 8 and y equals x minus 2. Without graphing this is gonna have what type of solution or how many? One. No solution would be if they have the same slope, they're parallel. Infinitely many would be if they're exactly the same. So this is gonna have one, we just have to figure out what that one is. So let's graph these both. I'm graphing the red one for my red one first. Y equals x minus 2. But it doesn't matter. For this one, the 3x plus 8, if you went up 3 to the right one, it would be off the graph. You could do that, but you don't have to. But you'd have to go down 3 and left 1 to get the rest of those ones. Where do those two lines cross? Yes. Yes, you need to fill up the graph. Put all slope points. Are there any others on this page we want to see, do, go over, have questions about? Are there any on this page we want to see, you go over, have questions about? Does it not say? Does it say who it's from? I did want to show you how to graph your infinitely many, because I don't want you to graph the line twice. I believe 4 is going to be that. So let's solve this first one. Subtract x on both sides. And divide both sides, or divide everything by 2. Y equals negative 1/2 x plus 2. For looking at these two equations, they're identical. They're exactly the same. So you wouldn't really graph this twice. So you have different options on how you could show this. You could graph one. So go ahead and graph one of them, doesn't matter. And then to show the other one, you could do one of these three things. Either after you've drawn this, draw like another set of arrows after it. So like it has double arrows to show that there's like two lines there, even though we only drew one. You could highlight over it to show that there are two lines, or you could draw directly on top of it with another color to show that there are two lines. You can't just draw one line though. You have to show something to show that there are two lines. And then your solution would be infinitely many, the infinity symbol, or IMS. Parallel lines are just two separate lines. Okay, we'll do one last thing today and then we'll stop. On the next page. If I had this system of equations and I had this solution, how could I check to see that this is my actual solution? What could I do? You could graph it and see, do they cross at that point? What else could we do algebraically? Solve it how? So you could do that. You could set this equal to this, solve it when we get into solving algebraically by substitution and elimination. That will be something we talk about. What else could we do? But that might take longer than what I'm. Let's think back to our regular equations. If we got a solution at the end, how could we check to make sure that is the right solution? Put it in the equation. So same thing here. Take these, put them into the equations, but it has to work for both. If it works for both, then you can see this as a solution. So this is a good way to check yourself. Like at the end, you get this as a solution. You can use this as a double check or a way to double check yourself when you're solving algebraically or by graphing. So this is your xy. Every time you see an x, put that in. Every time you see a y, put that in. So this would be 2 equals negative 1/3 times 3 plus 3. 2 equals negative 1 plus 3. Negative 1 plus 3 give us 2. So that works. But again, it has to work for both. If it doesn't work for both, then it's not the solution. So let's test the other one. 2 equals 2 times 3 minus 4. We have 2 equals 6 minus 4. Does 6 minus 4 give us 2?
Yes.
So that works. So because it works for both, I can say this is the solution. If it doesn't work for both, then it won't. I lied. We'll just do one more and then we're done. To show you that how it works when it doesn't. So number 3, do the same thing. We do not need to solve this. We can leave it exactly as it is. So 4 minus 4 times negative 2 equals 12. Would be 4 plus 8 equals 12. Would that give us 12? 4 plus 8. Yes. Right, and then the other one, 3 times 4 minus 2 times negative 2 equals negative 12 plus 4 equals negative 4. Add those together, are we going to get negative 4? Because this one does not work, this could not be the solution to both. That would mean if you were checking yourself and did this, let's say you graphed it or did it algebraically, somewhere in your work or somewhere in your graph, you did something wrong, and you'd have to go back. We're gonna continue this page tomorrow. Yes.